I'm thinking of a number. I'm going to double the number and I'm going to add 5. My result is 13. What's my number? Well, if we think this through, if you think it through logically, then your final result was 13. But what you did right before you got the 13 was you added 5 to a number, and that took you up to 13. So if we subtract 5 from the end result, that'll take us back down to 8. Now we had to double the number we were thinking of to get 8. So what number do you double to get 8? Well, to undo doubling, we would divide by 2, because doubling is multiplying by 2, and 8 divided by 2 is 4. So our original number must have been 4, and if we check our work, let's see. I'm thinking of 4. If we double it, we get to 8, and then if we add 5, we get to 13. So indeed it works, but the big idea is when we're solving this, we're using deductive reasoning, we're going backwards to solve the problem. So we've just solved 2x plus 5 equals 13. How about 5 plus 2x equals 13? We would have had some number, we would have had to have doubled it, and then we would add 5 to it. Or we'd have add 5 to the result we got after we doubled the number. So either way you look at it, this guy had to be taken care of first, and then we added the 5 to get to 13. So once again, the first thing we do is take away the last thing that would have been done, and that was to subtract the 5. So we'd be left with 2x is equal to 8, and to undo multiplication by 2, we would divide by 2 and still arrive at the same number. So here let's do another one, and then we'll come up with some rules. Divide some unknown number by 5 and add 2 to it, and the resulting number is 11. What was the unknown number? Okay, so we started with a number, then we divided it by 5. Then we added 2, and we arrived at the number 11. So if we're going to solve this, we got to go backwards. The thing we did prior to getting to 11 was adding 2. So to undo the addition of 2, we would subtract 2 from the 11, and our number must have been 9. Because once we added 2 to 9, we got to 11. So we're working backwards. We're at 9. Well, how did we get to the 9 originally? Well, we had some number, and we divided by 5, and we got to the 9. So to undo division by 5, we would multiply by 5. So if we multiply this by 5, we get 45. That must have been the number that we started with. 45 divided by 5 is 9. Then if you add 2, you get 11. So the big idea is that we go backwards in the reverse order of which we took to arrive at our final result. So working backwards through the order of operations. So here's what we have. We have x divided by 5 plus 2 is equal to 11. We're thinking of number, we divide it by 5, we add 2 and we get 11. And we just agreed that the proper thing to do here was to subtract 2 from both sides of the equation, leaving with x divided by 5 is equal to 9, and then to undo division by 5, we would multiply both sides by 5, and when we multiply, we get x is equal to 45. We're going to take a little closer look at this in a second. Now, this equation is equivalent to that equation. Doesn't matter how we write it, we're actually going to do the exact same order of steps to arrive at the final answer. Because whatever x was, before you could take 2 plus that quantity, you had to figure out what x divided by 5 was. Then you could add 2 to that number. And so since what happened first was division by 5 anyway, and then we added 2 to that result, it's really the same problem. So to undo this, we subtract 2 from both sides. We're still left with x divided by 5 is equal to 9, and we still multiply both sides by 5 to end up with x equals 45. So once again, the order of operations, or the sophistication of the order of operations, is going to dictate how we undo what was originally done to the variable. So we're going to be going in reverse order of operations. So let's tie this up more concisely. Here's what we should do. When you come to an equation, focus on the variable side and assess the order of operations initially done. So we go over here. We go to the variable side. Whatever number we were thinking of, order of operations dictates that the multiplication by -3 would have happened first. then you would have taken 5 away from the result to end up at 19. So once we've assessed the order of operations, we are going to undo the initial operations by going in reverse order. So initially we would have multiplied first and then subtracted, but to solve the problem, we go backwards through the process. So we take care of the lesser operations first. Got to get rid of subtraction by 5, so we're going to add 5 to both sides of the equation. Now if we show that step, negative 5 plus 5 is 0. We're going to be creating zeros and ones appropriately. So what we have, we're down to negative 3x plus 0 is equal to, well, 19 plus 25, or 19 plus 5 is equal to 24. Well, we know that anything that 0 gets added to is just that value. That's why we wanted the 0 there. So really, we're just down to this step right here, and I think we all know what to do there. To undo multiplication by negative 3, we would go ahead and divide by negative 3 on both sides. It's the side where the variable is that dictates. Negative 3x divided by negative 3 is 1x. We created a 1 exactly where we wanted it. It's the multiplicative identity. So 1 times x is just x. We're left with negative 8. You can always check your answer. Put that back in. Negative 3 times negative 8 is 24. Minus 5 is 19. And let's do this one. Focus on the variable side. Assess the order of operations that initially happened. Over here, we took negative 7 plus this result. But that meant that we had to take care of this result before we could do the operation of addition. So once again, when we initially figured out this situation, whatever t was, it had to get divided by 2 first. Then you could take the negative 7 plus that result. So initially, the division was done first and then the addition. So how are we going to solve this? We're going to undo the order of operations. We're going to take care of the addition first. Well, we need to get this number to 0, because when it comes to addition, if we can have 0 plus t divided by 2, then we've taken care of things. That went bye-bye, and all we're left with is t divided by 2. So what can we do with the negative 7 to create a 0? We can add 7 to create the 0. And whatever we do on the one side, we do on the other side. 4 plus 7 is 11, and 0 plus t over 2 is just t divided by 2. And I think we can see the final step. How do we undo the unknown number being divided by 2? Well, we could turn around then and multiply both sides by 2. This gives us 22. This gives us 1t. We created a 1, which is just t is equal to 22. Check our work. Negative 7 plus 22 divided by 2. We have to do the 22 divided by 2 first. That was our point. That gives us 11. Negative 7 plus 11 is 4. Correct answer. Uh-oh, fractions. Assess the order of operations on the side where the variable is. So the variable is on the left side. There's subtraction and there's multiplication. Multiplication would have been done first, then 16 minus that result to give us the 4. So we're going reverse order of operations. We will take care of the less sophisticated operation of subtraction before we take care of the multiplication. So, knowing that we have subtraction or addition, we would like to create a 0 right here. A 0 minus 2/3 y is what we'd like to see have happen. So how do we get rid of 16 so that there's only a 0 left? We would subtract 16 from both sides. Does that surprise some of us to see that even though there's a subtraction sign, the way to create the 0 is to take away 16? Some students get tripped up and they say, that's subtraction, let me do addition. No, not exactly. Your goal is to create the 0, the additive identity. Make the 16 go bye-bye by subtracting 16 to create a 0. All right, now if we do that to both sides, let's be careful. Over here, 4 minus 16 is negative 12. Over here, by creating the 0, we recognize that 0 minus 2/3 y is really a negative 2/3 y. Just like 0 minus 4 would be a negative 4. So we get negative 2/3 y is equal to negative 12. By carefully creating the 0, we realize that this is minus 2/3 y and we're left with the negative there. Guarantee a lot of kids make mistakes in that step right there. Good math will lead to the right answer. So finally, negative 2/3 y is equal to negative 12. to undo multiplication by this variable, we could, by this fraction, we could either divide by the fraction, or I'd rather we said, you know what, my goal is to create 1 times y. I know how to create 1 times y. I'll multiply by the inverse of that fraction, so I create the number 1. That's what inverses do. And whatever we do to one side, we'll do to the other side. We'll also multiply this by -3 over 2. So put that over 1. On the right side, we have a negative times a negative, which we know is a positive. We can cross-cancel the 12 and the 2. They have a common factor of 2. 12 divided by 2 is 6. That 2 divided by 2 is 1. So our final answer, again, negative times negative is positive. So 6 times 3 is 18 divided by 1. So our final answer, y is equal to 18. Check your answer. With a tricky problem like this, make sure that 18 works, and it does if you went back and checked it out. Inequalities are solved the same way as equations. Just look out for that big exception. When you multiply or divide both sides by a negative, then you got to switch the direction of the inequality sign. So we have the same 3 steps. Add that little guy. Don't forget to switch the inequality if you multiply or divide by a negative. Focus on the variable side. Here's the variable side. What operation was done first initially to create a situation where we had a result greater than or equal to 7? Well, we took m times that, and then we subtracted 3. So let's undo that in the reverse order. Let's take care of subtraction first. We need to add a 3 to this to create a 0. And we'll add a 3 to this side to keep both sides equal. So we're going to get 10 here. We've still got the greater than or equal to sign, the at least sign. And over here, we have 2/7 m minus 0 or plus 0, either way you want to look at it. But that's good. The 0 doesn't affect things. So we're just left with 2/7 m is greater than or equal to 10. When it's being multiplied, a number is being multiplied by m, we'd like to create a 1m. Easiest way to create a 1, multiply by the inverse. We know that gives you 1. Then do the same thing on this side. I'd prefer to multiply on the left side just as a purist. But anyways, here we go. I'll put that over 1. 2 and 10 have a common factor of 2. 2 divided by 2 is 1. 10 divided by 2 is 5. 7 times 5 is 35 over 1. So we're left with m is greater than or equal to 35. We don't switch the sign because we didn't multiply or divide both sides by a negative. Finally, let's do this puppy right here. Focus on the variable side. So if we look on the variable side, we've got, let's do it with the blue. We've got this going on. We took -6 minus the result that you got when you multiplied 12 times x. So you would have had to multiply 12 times x first to get that result, then do -6 minus that. So we'll go in reverse order of operations. We'll deal with the number involved in subtraction first. We need to create a 0, so we're going to add 6 to create that 0. Over here, we're going to add 6 on this side as well. We'll be left with -24, the less than sign, and then here again is where you don't want to make the mistake. By recognizing that -6 plus 6 gives it that key number, write down the rest of the problem, which is subtract 12x. 0 minus something gives you the negative of that something. So we are left with -12x on that side and -24 here. Last step, we want to undo multiplication of the x by a -12. We can see that as a negative. So we can divide this by a -12, and we can, here we go, we just divided both sides by a negative. So it's really even at that moment when we divide both sides by a negative that this sign should actually switch. So I'd love to see that we actually switch the sign right then and there. This divided by this is a +2. That has to be greater than this divided by this, which is 1x. So we're left with 2 is greater than x, or x is less than 2. So there you go. That's a first initial run through solving equations requiring more than one step.